around. We'd have beer, pizza, maybe we talk to each other in between. Hopefully you, wherever you are in the world, whatever time it is, you have beer and pizza. Even if it's silly o'clock in the morning, then I think it's okay to have beer and pizza because you're at a meetup, which is the correct thing to do. So we're going to have a few speakers. We're going to have Matthew Hodgson, who is from Matrix. He's the Matrix man. He's going to talk to us about the importance of decentralization and these kinds of things. We have Saúl from Jitsi. Jitsi has been having a crazy time because everybody is so excited about decentralized messaging. So we're gonna hear from them. Then we're gonna hear from David from IPFS, who are going to introduce some of their new features, including libp2p. And then we're going to hear from Valère. Valère is ironically, it's not complicated once it's working because it simplifies end-to-end encryption for everybody and makes everybody's life a lot easier. It's a great feature. So with that, I'm going to hand over to Matthew Hodgson.
Well, hi everybody. Thank you for joining. Is the stream working okay? I'm getting some weird feedback from somewhere. Does this ring a bell?
Yeah, I'm trying to.
Me too. I think the only person that is unmuted.
I'm muted. I can hear that too.
Okay. It stopped seemingly now. I'm wondering whether I had it might be just some random thing on my browser running in the background. But either way, it stopped now, so I'll continue. Well, welcome everybody. Thanks, Ben, very much for putting this together, and thank you for our guests to come on the meetup and talk through exciting stuff. As Ben says, it's very, very topical to be talking both about Jitsi and libp2p. We're incredibly excited to have
the best people in the space to talk to us about those today. On my side, I'm not going to say very much, mainly because I suspect a lot of people have fed up with me talking too much, particularly after live streaming or trying to live stream a Matrix and a Jitsi install over the weekend that lots of people seem to have seen now, unfortunately. And I don't have any slides either. Wanted to try to explain why we were doing this as a meetup and what open tech is in this context and why we think it might save us. Honestly, it's a bit of an exaggeration. Let's face it, the last couple of weeks have been a bit challenging for pretty much everybody in the world, and it feels like there's something that should be saving us from this. In no way do we think that open tech is actually going to save us from whatever challenges we face in our life, but it can certainly make things a lot easier. And by open tech here, obviously very, very broad term. We didn't want to call it a decentralization meetup or a decentralized comms meetup because it's quite specific. We want to run this every month on the second Wednesday of every month in this time slot, if it works for people. So that's 6 p.m. London, 5 p.m. GMT, 10 a.m. Pacific time, I believe. And the idea is to have as many people on who are doing cool stuff with open standards, open source, open APIs, open technology of any kind, where we are putting power in the hands of the user and in the power of the developer, in the hands of the developer. So basically not locking people away in proprietary silos, proprietary APIs, vendor locked into companies who go and embrace, extend and extinguish, or do all the other bad habits that we've seen over the years, and instead just try to keep the joy of open source and open communication protocols and open protocols alive, because we need it now more than ever in terms of the risks of the very big guys getting a bit complacent, not perhaps looking after their security as much as they should, and we end up in this horrible mess where we end up beholden to some big folks in Silicon Valley who might sometimes optimize for shareholder value over the well-being of their users. And open technologies gives us the opportunity to run things on our own terms and to have the choice to select which Jitsi I use, which Matrix server I use, which XMPP server I use in order to communicate, or indeed who I want to host my blog with, or who I want to host my email with. It's the best thing about the internet, and frankly, it's dying over the last 4 or 5 years, particularly as more and more people think, well, you know, the internet's kind of synonymous with Google. It's basically the same thing as Facebook. People who don't understand the difference between a browse, Facebook, and this sort of heroic dystopia. And I think we've got enough dystopias going on at the moment without that one being worse. So the whole idea here is to get the people together who are doing the most interesting things to liberate technology, put it back in the hands of everybody to use as best they can, and to keep the vibrant dream of the open web alive somewhere where anybody can develop to run their own technology, whether that's on the good old HTTP and DNS world, or perhaps a brave new decentralized world of IPFS or peer-to-peer matrix. Who knows? It's the end goal is the same, to really empower people to be able to build the technology that they want in their lives, and for users to be able to control the technology and their data on their own terms, rather than being bullied around by some big corporate who might be optimizing to addict them rather than to actually give them a good experience, which is hopefully something that will be good for them too. So there we have it. Sorry for the rant. I should give a quick update on things on Matrix. Probably the most interesting thing that we've had, well, first of all, in the last couple of weeks has been an explosion in activity. Probably not quite as big as Jitsi have been seeing, but we saw 10 times the signups at the beginning of the lockdown periods in Europe than we'd been seeing previously. That's kind of dropped down to about 3 or 4 times. Excitingly, people are hanging around. Where you look to see how many people make it into their second day of using Matrix, how many people flee in their first 24 hours, and it's up about 10% on normal, despite lots and lots of people coming in, which is pretty cool. Matrix.org as a home server has been on fire constantly, saturating CPU, sometimes taking tens of seconds to send messages, for which we apologize. We've been frantically scrabbling around to do a couple of incremental improvements on this, which have helped a lot, and it's almost usable over the last week. However, we've really stepped up the effort to scale Matrix horizontally on Synapse, our existing Python server. So we've done this by clustering using Redis, going and structuring it so that the master process, which you use to host your Synapse, has historically been a single point of failure. It's the only place that can write to the database effectively. And so whilst you can spin out other bits of functionality, like the media repository, the sync streams, sending events, in the end, the bit which writes to the database is a single Python process, which cannot scale beyond a single core. So Eric has been leading the charge on this over the last couple of weeks, frantically locked away in a dungeon, almost literally, thanks to the magic of the lockdown, to do nothing but focus on splitting out the replication streams such you can have multiple masters writing out these replication to the other services which make up Synapse, using Redis as the pub sub plane for that. And it's looking promising. It's not there yet. We're hopefully turning on Redis in the next couple of days, I think, for the existing topology, and then we'll finish off splitting out the other streams and have it running multi-master, which will allow us to scale good old Synapse to be beyond a single CPU core on that master point, at which point send time should be down to 20-30 milliseconds rather than spiking up to multiple seconds. The other interesting thing that I think I can announce, unless I'm stealing some of Valère's thunder for his talk later, is that we have a hard, not a hard deadline, but we have an explicit time to go and turn on end-to-end encryption across all of Matrix on the main apps as of next week on Thursday. So that will be Thursday the 16th of April that we're planning to flip the switch and turn on E2E for all DMs, all new DMs, and indeed all new private rooms by default. On the DMs, you won't be able to opt out. On the private rooms, you'll have the option to toggle it off if you know that this private group doesn't need to be encrypted, or you need to use integrations that don't yet talk E2E. So this is basically the end of all of the work that we announced back in February at FOSDEM, where we showed E2E by default running on the developed branches of Riot Web and iOS and Riot X. since then, it's been 2 months of very intense beta, redesigning bits of it where we'd made a couple of mistakes, ironing out the bugs, iterating on the UX, trying to actually make sure that we get the right UX. But as we shall see in Valère's demo at the end, it's hopefully very, very close. So close that we are putting out a date, and hopefully we'll be able to stick to it come next Thursday. So watch your space, as Riot has the biggest UX change it has ever had, I think, across all 3 platforms simultaneously, as we do the equivalent of forcing the entire email ecosystem to use PGP, whether they want to or not. But for Matrix, what can possibly go wrong? So we'll talk more about that later. That's probably it for me. Sorry for waffling on a bit. Back to you, Ben. Any questions? Any comments or anything?
We haven't had any questions for you in the room. I think people already know, they know the topics that we're going to cover. Matrix is progressing, and the importance of owning your data. So I'm gonna introduce Saúl. Saúl is working for Jitsi, and they are experiencing just phenomenal growth like they've never known before. So I gather that they've kind of conquered all the issues that they had, which were a few at the start. But I think that you guys are really on top of it now. So I'm going to let Saúl speak to that. Just a sec, because I unmute him. Oh, he is unmuted. Great.
I just unmuted. Thanks, Ben, and thanks, Matt, for thanks to both of you for putting this together. It's really an honor to be here sharing this with you. My aim for today is to sort of share a story of blood, sweat, tears, and love a little bit. It has been a huge roller coaster. And my purpose is to humbly share what we learned, what we did, what we failed at, and what we didn't fail at. So I did prepare a presentation, and I am going to put myself down there, and I'm gonna go through it, and hopefully this is something that can benefit the broader community. So of course, things were reasonably simple for us. Like, life was calm before this storm. So Jitsi Meet has always grown slowly, organically. Like, we didn't try to push it. Of course, we did our fair share of social media ragtag marketing, but nothing like, like a super dedicated action. We just put it there, put our head down, work on it, rinse and repeat. And we just focused on doing that. This was simple times where we were handling tens of servers, and that was that. And I'm going to go through the architecture that we are running on Jitsi, so that to give you an idea of what we had, what we have, and how this was instrumental to handling this growth that we have at this very moment. So we, first and foremost, we run all our infrastructure on AWS at the moment. And we have this concept of, we call it the shard. And it basically consists of a signaling node that runs Nginx, Prosody, and Gcofo, which is your conference focus. You can think of this as what handles all the signaling. That's why I call it that way. And then we have the media nodes, which is what relays your media, and that's all the cool video routing stuff. Those are our video bridges. And media nodes are configured in such a way that they can auto-scale based on load. So ideally, when the bridges in a given shard are too heated, new ones will spawn and join the herd and being able to handle the load. Now, this is one shard, but we have many of these, and we have separated them across AWS regions. So how does a region look like? So region has multiple shards. Here, I put 3 of them, of course, as an example. And in front of the shards, we have a cluster of HA proxies. We have 2 here, but we have regions with more than 2. And what these HA proxies do is that when a request comes to them, they will send it to either any one shard or one specific shard. So all the HA proxies are synchronized between them with some stick tables. And what this accomplishes is that we know if a meeting is happening on the first shard, we need to send all the participants to this shard. So this information is kept in this stick table so that HA proxy knows that the next participant on the same meeting needs to go to the same place instead of throwing it in a different shard, and then we would end up with a split brain situation. Now, as you can see that we have something in front of both of HA proxies, and that's the ALB, so the application load balancer, and that does a basic round robin over the 2 or more HA proxies on a given region. And then how do we connect the multiple regions? So we use the combo of Route 53 and the global accelerator. And what this allows us to do is to route participants to the region that they are closer to. So when a participant wants to join a meeting, they will, of course, do a DNS request to when they enter their URL in the browser. And then once that's looked up, thanks to Global Accelerator and Route 53, they will get one of 2 IP addresses, which are anycasted, and they will end up in the ALB for the region that is closer to them. So, for example, if I start a meeting, I will generally end up in Europe Central or Europe West. We're going to talk about regions a little bit further in the presentation. You guys would end up in London, for example, and so on. Before the crisis started, we had all of these locations deployed, so US East, US West, South America, Pacific, Australia, and 2 regions in Europe. Aside than having shards, we also have turn servers because we have this optimization so that peer-to-peer calls don't traverse the video bridge. They go directly between peers, and turn helps us do that. And we have deployed turn servers in all regions so that we can lower the latency across peer-to-peer participants. Now, this infrastructure was put together in 2015. And at the time, this was overkill because we only auto-scaled once or twice a year. So it remained, slowly, steadily handling all the load and not needing to do much. So thanks a lot, past Jitsi team, because the present Jitsi team is very thankful that we have this to rely on, because having this in place was key to being able to handle the load that we have today. So, of course, the news was starting to spread that this was a big problem and that some countries were going into lockdown and whatnot. So we tried to get ready. So when the news broke out that Italy was, for example, shutting down the schools, we tried to beef up our infrastructure, over provisioned, throwing more shards, more servers, and we hoped for the best. I'm now going to go through some sort of stages, if you will, but think of all of these things that I'm going to say as actions that happen not sequentially, but concurrently for the most part. So first, it was the Italian flood. This was our first week on this brand new world where everybody is doing video conferencing of sorts. And there was a huge traffic spike, mainly caused by Italy's lockdown. And the surge in traffic was just brutal. So here is our region from before, and our bridges started to burn like hell, dropping packets like crazy. Then our signaling nodes also were handling too much traffic or couldn't handle the traffic, so they were also on fire. This resulted in 502s, 504s to users because there is no signaling that can be established. Also, these what happened is that you join the room and you feel like you're alone, and this is because signaling wouldn't be able to connect and establish this link. Then, of course, through the back pressure that was happening, the HA proxies also started to burn. Everything was on fire, basically. So what went wrong in this traffic spike? So first of all, panic mode was full on. Everybody was freaking out. We were all hands on deck trying to scramble and solve things. We had tens of millions of dropped video packets. Our pagers were going off non-stop. Users were getting 504s left and right, first in one region, then in the next one. Tons of users were leaving one-star reviews on mobile app stores. And personally, at one point, I had to even turn off those notifications because they were driving me to the ground, really. It was so devastating. Some people, people tend to voice more their complaints than when they're happy. So everything was negative, everything. Hundreds of support emails and forum blog posts, which we probably haven't caught up, actually. We haven't been able to reply to all of you. So I apologize for that. We apologize for it because it overran us. One of the Italy's, I think is the biggest, but I'm not sure, online school is called WeSchool, and they're using us to sort of be able to, for students to still go to class and whatnot. And they were using Jitsi, and we were talking with them over Telegram, and we had like terrible reports in the first week. So all in all, it was brutal. But at one point, again, and concurrently, we were all investigating. Everybody in the team was trying to help understand what was going on and what we could do. So we found some light. The first problem we could solve was that we realized that our file descriptor limits in our signaling nodes, so Prosody and Nginx, were not configured properly. They were too low. And at this point, the car is running and you need to change the wheels while it runs. So we cowboyed our way through it by using PR limit, which at least I wasn't familiar with this at the time. It allows you to change this value at the runtime for an application that is already running instead of needing to restart it, which would be bad, even though we did do more than one full infrastructure reboots in this period. So this gave us a little bit more legroom, but usually the interesting thing that happened when we did this, when we solved one problem, is that another problem became more apparent because it was being masked by the first one. So the next problem we ran into was ephemeral port exhaustion. So basically, if you have a load balancer that is sending traffic to your application, and if the load balancer is using the same origin, so source IP and port, like you can only have 65,536 active connections between one source IP and port and one destination IP and port. On every connection, a new ephemeral port is allocated. And we were running into this limit because of how our signaling works. Many connections are established continuously. So we were hitting these limits. And we also had some arcane HA proxy configs. So we fixed those, and we could add more IP addresses to the ALB so that it would send traffic from more than one place to more than one place, so more HA proxies and also more IPs on them. And this multiplied that number of connections that we could handle. And then this way we could solve this bottleneck and handle much more signaling traffic. Last is inter-server traffic. We used to have all the bridges in any region connected to all the signaling nodes. This was so that we could use technology we have called Octo, which allows cascaded bridges. Basically, what happens is you have you would connect to the bridge that is closer to you in a region, and then this bridge would connect to another bridge in another region, and we will do the routing this way instead of having you connect to a remote bridge. At any rate, the problem with this was that all of these connections, all the chatter, because all the bridges need to publish statistics on how loaded they are so that the load balancing can work. All that chatter actually shut off part of our infrastructure because it was just too much. So what we did is what the previous diagrams showed. So each bridge only connects to their shard for now. We are actually working right now to enable Octo, this technology, to do cascaded bridges as an optimization. And I'm going to mention that in a little bit as well. And so this lasted for days. And our stand-up turned into a sit room. So every day we would go in, and the morning firefighting crew would tell the afternoon firefighting crew what happened, what countermeasures we could do. Oh, I found that HA proxy is not being able to cope with the load. Can you guys check if you can tweak it some more? And things like that, right? Until we reach some stability. At the same time, we started realizing some patterns in the feedback we were receiving. So, for example, we saw a huge surge in our mobile app usage, like crazy, in the thousands %. And the two most common complaints were, I don't know how to invite other people to my meeting, and probably because of all the schooling that has been happening on our platform, how do I raise my hand? Both features were there, but they were sort of buried 2 menus away and not easily accessible. So we managed to roll out an update pretty quickly that made these options more obvious and easier to access. So in the first screenshot there on the left, you can see this is what we call our lonely experience. And this is shown when you join a meeting, but you're alone. And we have the invite others button. And this allows you to quickly bring the system share sheet to invite others via email, probably even Riot, WhatsApp, Signal, Telegram, anything that can send a text message should show up on the list. And as you can see in the one in the middle, we brought the raise your hand button to the front as well, to the first menu that you can access with those 3 dots there. To make it easier for users to use. And the other options that may not be used that frequently ended up on the third menu that are there. And then next, we turn it up to 11. Like, we deployed servers. We deployed all of the servers, like crazy stuff. We first did 50 times the infra, and then at one point we even had, like, we don't count that way anymore because it doesn't make sense. We're in the thousands of servers instead of in tens. So this was the magnitude that was needed at one point to be able to handle with the ever increasing load. Because what was happening was that one day you would be able to maybe handle the load, and then the next day you have almost double. And this was on a daily for a week. And then, you know, the growth becomes a little bit more manageable. But it was brutal in the beginning. So in addition to all of these improvements, we also noticed, you know, in the news, in the traffic, that that France and Spain were likely going to be next, and they were in terms of traffic. So we deployed the new AWS region, so that's EU West 3 in Paris. And we started the new region with a ton of shards as well to sort of beef up all those users and being able to give them service closer to home. We also increase our turn servers everywhere because we did see that multi-people meetings increased more than peer-to-peer meetings, but those are still very, very significant. So one-to-one calls, and we wanted to also make it work for those. We used AWS's global accelerator, as I mentioned earlier, the thing that works in combination with Route 53. So this was instrumental to allow us to actually deflect traffic from one zone to another, because even if we deploy EU West 3, so Paris, there's still a lot more traffic coming from Italy that would end up in EU Central, so Frankfurt. So thanks to the global accelerator, with a couple of clicks, we can say, well, you know, lower EU Central to maybe like 80, 70%, and then the rest of the traffic would spread across the other regions by proximity. So some of the traffic would go to Paris, which is still not too bad. It's not like going to the other face of the planet, or to even London, and thus. So we could, like, this is something we have been, for instance, tweaking by hand when need be, to make sure that even if we have enough servers, they, like, the load geographically gets spread out a little bit more evenly, because the load itself is just not even at the moment. So as Ben and Matt have mentioned, we did see some huge increase in many factors. So to give you an idea, we are now getting 60 times more conferences than before this whole thing started. We're handling over 100 times more participants, and we're relaying almost 200 times more traffic. And in terms of infrastructure, we are now managing servers in the thousands, and before it was in the tens. Like when something failed, we could SSH somewhere and do something. Right now, that is crazy / impossible. As one of the latest things we've been working on is we streamlined our approach to auto scaling to try to be faster, and we can now scale up hundreds of bridges per second when load increases. So typically at 9 a.m. is when the load starts a huge climb, and we have servers that are running all the time, but autoscale will kick off and then start a lot more servers to be able to handle with all this load. Now this is not over, of course, but right now we are at the point where we seem to be able to cope with the load. Our one-star reviews are going down. Users seem to be more satisfied, which is very important for us, because that's why we spent our blood, sweat, and tears. We did get the love, so that was like really, really nice to give us fuel to keep pushing. So now we have a little bit of time to also try to see beyond tomorrow or next week, right? Try to see a little bit further. What do we do next? So of course, ever growing your infrastructure is not something that scales, puns intended. So we are optimizing, we're working on optimizing our use of the resources. So for example, transit is a big part of the cost if you run on Amazon, and an optimization there would be by moving our video bridges, which are the video routers that move the video packets around, out of AWS into dedicated data centers, for instance. This would be an optimization we're looking into right now. I mentioned that our HA proxies have stick tables that are synchronized across them, and that's how you find like the right shard. But at this point, split brains are basically unavoidable, and we estimate that at any one point in time, there is one room which is in split brain mode. We're not happy about this, and we have plans to replace this by using a service that is backed by either DynamoDB or Redis, so we can have this one place where we keep active rooms and we can know where to route it instead of relying on this synchronization mechanism. We should also be able to address more feedback. Keep it coming, please. We have pushed new features I think yesterday or the day before yesterday, we sent out a blog post with our April update. These were things that we managed to get done despite the current situation, but sometimes it's not despite, it's because of it. Because as more people use our service, we realize that we have had lacking UI or UX experience, and we have prioritized certain features, and we have been pushing this out basically as fast as we can. I'm almost done, but before I open it for questions, there's some groups of people I'd like to thank too, both on behalf of the team and on a personal level. So first and foremost is our users. We wouldn't be able to be where we are right now to do what we do without the trust that users have put on us. Thanks to everyone who has recommended Jitsi to, the friends, family, whoever, doesn't matter. Thanks to those of you who have actually contributed to our documentation and translations. We have seen a huge spike in contributions in this. And it makes me really happy because these are the two areas that people typically say when they say you don't need to know how to code to contribute to open source. But sometimes when people say it feels a bit gimmicky, but I have seen it before my eyes. That tons of people are just helping. Oh, this language is wrong. Oh, look, I can help with this documentation. Hopefully many people know, but you can self-host Jitsi Meet. That's actually what we encourage people to do. We appreciate your trust, but you don't have to. You can take the software and run it yourself. As Matt has said, you can own everything yourself. And we have seen lots of videos explaining things like Matt's video and some others. So we thank those people as well. I'd also like to thank 8x8 for doing the right thing here and going all out to help get this service running for everybody that relied on it, no matter what. Last, and this is something that it hit me really hard, like nothing else in my career. I'd like to thank everybody who is helping to keep their relatives, family, everybody safe, all those medical personnel that are at risk themselves. And especially, so we got this message and these pictures from Massimo, who works in a hospital in Italy. It's not like they're idling. They have lots of stuff to do. But they set up this project where they took some donated tablets to help patients communicate with their families. And he sent this thank you note because they were using Jitsi and people found it easy enough to use that they could communicate. And in these times, that was something. And this really hit home. Like, it's very hard to describe what I felt and what everybody that I've shared this news with felt, because this is really sort of, it gives you purpose. We would do this all over again every day of the week and twice on Sunday. Thanks a lot. And that is sort of all I had.
So thank you very much. That was phenomenal. That was really, really fascinating. And thank you so much for the work on Jitsi Meet. I know how frustrating it can be to, you say you've gone up by 60x and you've got thousands of servers instead of tens of servers, which you had last, 2 months ago. And still, people are not always appreciative, and, the people in the app stores and things can't be appreciative. So it's fantastic that you're doing this. We had a bunch of comments while you were speaking. Shardim, somebody says, +1 for Jitsi Meet. We encountered a few of the hiccups, but it's still fantastic.
Thanks for that.
Ilmari, I've been using Jitsi Meet for several virtual pub meetups in the last week. I'm very happy with it. Syntax says, hats off for Jitsi for their efforts. So yeah, everybody's really behind you and doing, really wants you to be doing the right thing.
Yeah. Really thankful for all the love we've received. Like, this was unprecedented for us. Sometimes we don't really know how to deal with it because it's both, it has been a true roller coaster. So some days you're like down, some days you're trying, like, oh, things look like they worked today. You're riding the wave, but then you're humbled hard next day,
Yeah.
because you can't. And at least now looks like we managed to get our head above the water level,
Right.
and at least be able to help everybody that is trying to communicate.
Yeah.
We've also seen a huge surge in our Debian packaging and Docker images, both use and bug reporting and whatnot. So thanks to everybody who is self-hosting and helping others self-host and helping us iron out bugs, reporting bugs. Everything helps. We might not be the speediest at these times with some things, but it will make everything better.
So I've got a good question here from MJW on that topic. Do you have estimates on how many Jitsi pieces there are and how many more recently?
So that is a great question, and it's hard to answer because we don't have any data. Because that's what we do. We don't hold your data, so we don't know. We don't phone home from the Docker setup, so we can't know. We know more people are using them, and I think it's publicly available if you go to, for instance, Docker Hub and you check how many pulls, but that means very little. Because people can build images themselves, and they are doing that all the time because it's one command away and you get to use the latest and the greatest instead of waiting for us to do releases. So, and the Debian packages, again, they don't really we don't have like that Debian popularity contest kind of thing.
Mm-hmm.
So we don't ask the users to tell us. But we have seen a huge surge in traffic in our community, so we think it has gone up by a lot. In our GitHub repo, the main one for Jitsi Meet, there is a wiki. So we have an open wiki, and people have assembled themselves and created this list of servers that are publicly available for people to use.
Yeah.
What SSL certificates they have, what stan servers they are using. Like, for instance, some people wouldn't want to use a server that uses Google's stan server. We used to have that stan server. We switched it in the last update to ourselves as well. So, lots of people have been helping out there.
Cool. All right, let me, sorry, I'm just putting questions together from this list. Do you have any update on the the Firefox improvements that were coming along? I know that this is partly on Mozilla's side to work on, but I don't know if you have an update.
No, so yeah, I think I can have an update. So some of the pieces that we were working on have already landed. In the pull requests are already landed. I think we might be able to enable some of this behavior with the next update. So one thing I forgot to mention was that in the first few days, as we discovered all these bugs, we were making pretty much releases daily to add fixes and add stuff. Now with thousands of servers, this is a bit more complicated. So we're working on streamlining that up, which means that the time between updates, unfortunately, is a little bit longer than we would want it to. But the Firefox fixes, I have reviewed and approved at least 2 pull requests in that regard.
Right.
And I think there was either 1 left or a couple left. So they are coming. The things that are on our side. Mozilla has some bugs that they need to fix, but I think it is fair to say that in order to have like a much better experience, that ball at this point was in our roof, and we have picked it up.
Phenomenal, thank you. So this is more of a fun one. We've got a few questions here for you, by the way, so I'm going to try and get through them. This is more of a fun one. What kind of, what's the biggest connection size you've seen, like number of participants? So we regularly do about 30, and we feel comfortable with it, but what's the biggest you've seen?
So we have, before this thing started, we were working on the 100-person meeting experience. Because this has more implications than meet the eye. So One is handling the load of having 100 participants, but then there are more things, right? So UX, UI wise, having 100 tiles just doesn't make a lot of sense. Generally, in a meeting with there's a certain threshold above which they're really mostly bystanders, and just a handful that are presenting content. So we're trying to see if we can find a balance in. So we have this technology we call last N, which basically means that the video bridge will only send you the video for the last N active participants. And this N is dynamic, and it adjusts based on the available bandwidth. But sometimes, for example, browsers are supposed to also use CPU overuse to throttle the bandwidth. Like, hey, my encoder is choking here. Send me a bit less, please. But it's a dark art. It's very hard to tweak. So we're thinking of strategies there where if your meeting is bigger than X, then maybe we only allow Y amount of senders and whatnot. So we were working on this. And when this whole thing broke, well, we basically, that is a little bit on hold, all the UI work related to that. And we put a cap on 75 right now on all meetings, just because we don't think you will have a good experience beyond. You already need to have a beefy machine to be able to be on a 75-person meeting. And there are other, like, we have solved some usability problems, what we think, for large meetings. Like we have in the update we posted yesterday, we launched 2 such features, which are mute everyone and mute everyone but this person.
Yep, I've been enjoying those features today.
It's very hard to manage a very large conference. So in our graphing, we see regularly daily meetings over 60 happening in our infrastructure. So those meetings happen, and there is a hard limit on 75. We've seen meetings reach that limit. So currently, that is the biggest meetings we're seeing. For larger ones, we always recommend live stream and have the speakers sort of like what we're doing here right now.
Yeah, exactly.
That's the strategy we have up until now.
The last N thing seems to work pretty well, though. I think we've got it on 12 or possibly 15 on our one. And the thing is that you just can't look at that many tiles at the same time. I guess you could be randomly staring at somebody who hasn't spoken in the last 15 people, but that's a bit weird. And in some ways, it's kind of good for them to have their video muted. So we tend to not even notice when that's happening. And yeah, it's been working really well for us with 40, 50, I think is the record that we've hit so far. But it's amazing how many people ask that as a fact to us. So I don't know whether you need to put something on the Jitsi site or something to...
Yeah, the problem with that is always forgetting about it and communication. So, for example, we have this video quality slider, right? Which right now it affects only the receive quality. So one of the things that we use is called simulcast, which means right now I am sending my video sort of 3 times. HD, VGA, and thumbnail quality, and the video bridge decides what video you need. Because if I'm not the active speaker in your screen, you don't need to see me on HD, for instance. But you may like click on someone and then they become the large one. So it is, if we add a setting for it, then you set it to something, then you come back the next day and things don't work the same, let's say, and you wonder, why am I seeing this wrong? And it's because you left it that way. Or like you, at that point, it's very hard to beat the browser itself and our bandwidth estimation algorithms are doing their work. If you try to overrule them, then you end up in like tricky situations. There are some situations that actually are meaningful in this scenario, and that's why we have the slider, and that's why you can go into what we call low bandwidth mode. For example, if you do have the bandwidth, but it's expensive, that's the one case, for instance, that is 100% warranted, and that's why you can lower the thing and go all the way to low bandwidth, and then you're good.
Makes sense.
Fab. All right, let's go on to some other questions. So one from a Noah. What if I end up in a region and my call is in another region? I think this is about your AWS architecture.
Yeah. So what would happen is that via Route 53, you will end up in, let's say that in a European region, in EU Central, but the conference is actually happening in a shard that is in US.
Yeah.
So because of those stick tables I mentioned and the synchronization between HA proxies, when the request arrives at the HA proxy in EU Central, it will look at the table and say, this room is in this shard, which is in US East. Actually, it doesn't matter where it is, just send it there. And it goes there. So that is what is happening. Today. Now we're in the process of redeploying Octo, and when we redeploy Octo, what will happen is that you will connect to not only to the shard that is closer to you, but also to a bridge that is closer to you. So you will get a bridge in Europe, and then bridge to bridge, your media will still go to the US, but it will go via Amazon's internal network. And
Right.
the peering is, well, supposed to be a lot better because it's an internal network.
Yeah. I mean, you're really leveraging the fact that Amazon's internal latency is so low. Okay, yeah, that makes a lot of sense. All right, so we've actually done quite a few questions. I'm going to just do one more because I think it's really interesting. I have a fear that it's a huge rabbit hole. Question from Kitsune. So, what do you use for automating access to all the servers? Before you said something like, "Oh, we used to just SSH, and now we can." You have something.
No, we didn't SSH, but what I said is we could. So we have an internal tool that uses Jenkins to run CloudFormation templates. Each machine also runs an Ansible script on boot that fetches the config and auto provisions itself.
Got it.
Does all the things. So, for example, the typical workflow you would do when we're firefighting is like, okay, we think this region needs more shards. So we have a quick web UI where we say, hey, provision more shards. And what that does is it runs a Jenkins job that uses the AWS with the Boto API in Python, creates, it will run, talk to Amazon and say, hey, we need more servers of these images. So I didn't actually say this, but we run all our things as VMs. And we create an image when we do a release. We say, let's say this is the image. And then what we do is basically we build a shard with the version of this image, the version of that image, the version of that image. We bring it live. We have another Jenkins job that would update HA proxies so that they learn about this new shard and they know how to route traffic to it. And then, it becomes live. So everything is automated via multiple Jenkins jobs and scripts that we've done using the AWS API. And we heavily use Amazon things like tagging and labeling of images. Now, that is another thing that probably I should have mentioned that we have realized, which is it doesn't scale to thousands of servers. Suddenly, you get that your AWS queries are rate limited because you're making too many of them. So you can't scale up, but you need to scale up because you're dying. So it's quite the predicament. And we are, as we move, as we think of these moving JVBs to a different data center, we are also going to move a little bit of that part of the architecture to use something like a registry, like a discovery mechanism, instead of relying on AWS specifics. But even when we change that, the one thing that remains the same is this architecture of shard servers that connect to each other. And last I'll say, because I've been here long enough, back to one of the points that Matt made about open standards. Some people may not know or realize that our signaling is 100% XMPP, and our servers talk to each other via XMPP. And we haven't reinvented servers connecting and pooling themselves. They connect to a group chat, to a MOOC, and exchange messages between them so that they know where you are and you pick a given bridge. All that stuff is implemented that way.
Hopefully someday we might be able to give you some matrix signaling too. But I know there's a project actually that we've been doing. I say Halfshot, who runs the bridges development on Matrix, has been doing a secret Jitsi bridge, which allows you to connect into Matrix, into Jitsi, into the MUX, but also get into the jingle signaling for the WebRTC from Matrix, so we can actually do VoIP in and out between Matrix and there. So it doesn't matter if you're using XMPP, we'll just go and bridge it. But,
that's really exciting. I didn't know that.
It's brand new. I'm sure he doesn't want me to talk about it, but okay. I'm sure there'll be more information in the next few days.
We won't tell anyone.
So I want to say thank you again. I wish you could see the live chat. Everybody's clapping you. So thank you very, very much.
Thanks a lot, guys. Very thankful for having me.
Thanks, Saúl.
So now I'm going to introduce David. David from IPFS is going to talk to us about gossipsub and the work that they've been doing for 1.1. I'm very curious about this myself, so I'd like to hear from David.
Yeah. Hi, everyone. Can you hear me well?
Yep, you're coming in through 5 by 5. You've got a bigger microphone than I do. I feel insecure.
should I like maybe I can drop it a little bit?
No, it's fine.
Let me know. So yeah, sorry about if I was unmuted during the session before. I was kind of like just going on and off. I was not sure if I was unmuted. I just switched to Chrome, so let me try to see if the screen share still works as I want it to. Okay, of course I have to give permissions, and it is asking me to quit the application. Can you give me 5 seconds just to reboot it?
Sorry. Don't worry, we'll cover for you. Ben, are you going to sing something? Ben is just looking paranoid and also on mute, so I guess you're left with me to cover things up. This is my fault for saying that we should use Chrome rather than Firefox, but it's back now.
You restarting? He's okay?
Yep. Hopefully. Right. Welcome back. You're muted though.
Okay, so now I'm back and I'm unmuted and I want to pick a screen. So now you should be able to see a screen with just like an island, and now you should be able to see a slide.
Yep.
All right, perfect. So hi everyone, thank you so much for the introduction. I'm David Diaz. I work for Protocol Labs in multiple projects, so IPFS, peer-to-peer, and also I'm creating a group called ResNet Lab that focuses on resilient network research. And I have to say, like, I'm really, really excited to be with you here today. And by the way, I think I killed my video. Did I?
You did. If you unmute, then apparently you will magically reappear in the corner. At least that's what Saúl said.
Okay, so now you can still see me in the slides.
Yep, we can.
All right. Sorry, I probably did a very complex setup for myself. I could have simplified this. So as I was saying, I'm really happy to be here. First, because I get to hang out with the Matrix and the Jitsi people and just catch up on like what everyone is doing. And second, because I get to share the work that the team has been building on peer-to-peer PubSub, namely gossipsub. So I prepared a presentation for you. I have like a bunch of slides, and I'm more than happy to take questions at the end. The presentation structure is I'll just start with a quick motivation of like why we focused on peer-to-peer PubSub in the first place. Then I will like just unpack for those of you that haven't heard about peer-to-peer PubSub in the first place. I will unpack the history and like why we have been like evolving its implementation. And then I will touch on the work that we have been doing recently about hardening gossipsub. So kind of like incrementing, augmenting the protocol to make it resilient to malicious actors. And then I'll finish with like, what are we still working on? What is left? What you could potentially contribute? And probably for those of you that have been following, the last two parts are the ones that are really interesting for you. So motivation for peer-to-peer PubSub. The motivation is very simple. We wanted to enable real-time applications on the IPFS with peer-to-peer networks. So we wanted to have applications on the Web3, the DWeb, to have the same rich experience that users are used to with the Web 2.0, right? Like users are used to applications that are fast, that are responsive, and we wanted to enable that. But we put a constraint to ourselves, which is we didn't want to rely on any piece of centralized infrastructure. So we wanted for everything to be part of the public network. And the first application that we built to test our assumptions, to test our technology, was Orbit Chat. So we showcased this application a few years ago at DEF CON, and it was the actual first application using peer-to-peer PubSub to create like a IRC-like application. So very simple, but like a chat application with rooms in which multiple users could join just with their browser, without having to install anything, without having to deploy anything to a server, or without even relying on a server to connect among themselves. Then more applications appear, like we got collaborative doc editors, we got decentralized markets, we got social networks, we got even applications that share virtual assets for augmented reality applications. So this one is always really cool. And then we got applications to share photos, and like many more applications came. And so there's like now a panoply of applications that either use PubSub directly or benefit from it in some capacity.
David, sorry to say, we're getting very bad quality video from you. Do you think you is there anything problems your end, or do you think you could just restart the browser?
So Chrome is telling me that I have low definition.
Ironically, it's fine now. But try muting your video preview. It was fine, I think, until you put that up, and then we were getting really low frame rate for some reason.
Is there a way for me to force it to like always go HD? So it says HD. I'll kill my video.
Just try it again now, and hopefully it should be all right. I mean, we were just about getting the slides, but okay, try now.
Can you see it now?
Yeah.
Like good enough? Okay, so we'll do it like this. All right, thank you. So yeah, lots of applications. And why? Like, what are the PubSub key benefits? Like, why this is such a good construction for applications? First, it's like message-oriented communication between applications, between agents. So it's very simple to understand and to implement. It has support for different topologies. So different kinds of applications, they have different kinds of interaction patterns. So something like PubSub can offer those kind of interaction patterns out of the box. As like by design, as this like very loose coupling construction, which means like we can separate the producers from the consumers in a very clean way, and it's actually scalable, right? Like it can adapt as the network grows, as the application grows its user base. But there are a lot of challenges with building a peer-to-peer PubSub system. We have a permissionless network, so we cannot control who joins and leaves. This adds a lot of challenges because we cannot just like remove malicious actors. The network topology is actually bottom up, so we cannot like just set up a broker to route the messages for every peer. We need to create a way for peers to organize themselves, to self-organize and create the best topology that they can come up with. There's a lot of network churn, so like there's a lot of peers coming and going, and if so, a peer had like an important role on propagating messages. We need to be aware that that can happen, so that we need a protocol that can like again self-organize, self-heal, so that the network doesn't lose quality. And then like eventually, as the application scales, as the network grows, a conversation starts about optimizing either for latency, for bandwidth, for delivery guarantees, and like we often have to make trade-offs. And as I said, there's also like the fact that people that join these networks, these permissionless networks, can be malicious actors. So they might have less than good intentions when participating in these networks. So that's the motivation, and that's like the challenges. So what have we built so far? Like, what is the evolution of peer-to-peer PubSub? And so it might be confusing at first because I keep saying that peer-to-peer PubSub and then gossipsub, and now I'm going to introduce one more name, floodsub. And to clarify that, like essentially peer-to-peer PubSub is an interface. It's an API that applications can rely on. Then these things like floodsub, gossipsub, or whatever other sub implementation appears in the future, they are actually router implementations. So they are actually parts of the protocol that decide how messages get forward, how the topologies of the network get constructed, etc. So you as a consumer, you can pick your own router implementation that better serves your needs, depending on your network scale, your needs, and you can even change it over time without having to change your application. And by peer-to-peer design, also, these router implementations are independent from the transports itself. So we can run a PubSub application that uses a transport like TCP, Quick, WebRTC, even Bluetooth, WebSockets, whatever you want to bring in. And we can even have clients that chat between these multiple transports. So you can have a browser chatting with a client. So a browser that only does WebRTC chatting with a client that does TCP, as long as they have some node in the middle that can speak both transports and do the relay for them. So the evolution, first we have the first router, FloodSub. And we started with FloodSub because it was really the simplest possible protocol that we could build. It didn't have its own peer discovery mechanism. It just relied on the IPFS main network, the DHT, to find other peers. And routing is achieved by flooding. That's why hence the name FloodSub. What does flooding mean? So I'm sure you have seen these summoning circles before. And so for FloodSub, the ritual is that when a peer wants to send a message, it will send the message through the connection that it has to the other peers. And then once those peers receive the message, they will also propagate that message to the other peers. So this looks good, right? Like seems efficient, like everyone got the message. But the name flood is because now all of the other peers will also try to send that message that they just received to all of the other peers, and flooding the network, which causes like a really huge bandwidth inefficiency. So the approach is really like FloodSub is super easy to implement. It's very robust if you think about it. Like it's really hard to attack this network. There is always a path to follow to get the message. And it optimizes for minimal latency because, well, the protocol doesn't even make a decision. It just picks all paths. So it will always pick the minimum latency path by consequence. And as I said, it's very bandwidth inefficient. So in order to visualize this, I actually bring up like a visual demo. So it should be playing on your screen, I hope. Let me know if it's not. But like what we are seeing here is a network of like 100 nodes with 5 messages being emitted. And like we just have like a run for 2 seconds. We expanded the time scale by 10 times so that we, as humans, could see what is happening. But you can see the number of like messages that get sent between all the nodes in the network. It becomes very intense, really, really, really fast. And as you know, and as we heard from the last presentation, bandwidth can be a very expensive resource, and it's also limited. And so if we abuse the bandwidth that we have available, we'll eventually like choke in ourselves and not be able to route all of the messages. So yeah, I believe this paints the picture. You got the idea. So this was like FloodSub. Then we got another implementation, and we call this RandomSub. We don't really talk about it a lot because it was just an experiment. We didn't even create a spec for it. And it was an experiment to see how the network performed if we, instead of like trying to flood and send the message to everyone, we actually randomly selected peers to forward the message. So this was like way less bandwidth intensive, but also had the problem that created dark spots. So there were nodes in the network that actually would never receive the message because there was no way for them to know first that there was a message to be received, to ask for the message if they didn't receive it, or for other nodes to understand that those nodes are excluded from the spanning tree, from the broadcast, and like send the message that they were missing. But this RandomSub, this experiment, was really a good experiment that then led to the next implementation, which is kind of like the current generation, which we call gossipsub. So gossipsub is a protocol that trades latency for bandwidth efficiency. And I'll explain more what this means in a sec. It has a self-stabilizing, a self-organizing algorithm. So like nodes know how to cooperate with each other to organize between themselves to create the best spanning tree, the best broadcast pathways between themselves. And one great addition of gossipsub is that it actually supports protocol extensions. So rather than being a straight protocol like the previous two, we can augment, we can have new versions. So gossipsub is in reality a hybrid of 2 networks. One network where the messages are passed through. So we call this the full message network. And then another network in which peers communicate metadata, such as messages that they have received, messages that they are looking for, etc., to help other peers help them, or help other peers make decisions about how to establish connections between themselves. And this is like the gossip part. So basically, there is a full message network where the messages get passed from the application, and then there is this gossip network where the state of the network gets propagated. On the full message network, we have these reciprocal peering agreements. What this means is if I agree with the peer to send all the messages I receive, that peer also will respond back, sending all the messages they receive. And we call this the connections that each peer has to each other a mesh. So think about like each peer has their own local mesh, like their own set of peers that they're connected to, that they have these peering agreements. And so they will like forward messages to those and get messages from them. We have some like default numbers. So by default, a peer tries to have at least 6 other connections. There is a lower bound and a upper bound in which like if we have less than the lower bound, we try to open more connections. If we have more than the upper bound, we try to drop some of the connections. But these numbers are just parameters that you can adjust. Then we have the metadata network. And by the way, if you're familiar with like networks and distributed systems, probably the names you heard in the past is the data plane and the control plane, and they map to these pretty well. And so in this metadata network, it's a very dense network. There is no really like a necessary topology. Peers will connect to each other and learn about each other. And they'll use this to communicate their local observed state through the gossip. Each peer keeps a partial view of the network. So they don't know about every single peer in the network, but they have a view of the peers that they have meshed with. And they have also knowledge of the peers that they are connected but not meshed with, so peers that they are not sending messages. When a peer joins, they will receive all of the subscriptions of the peers that they connect to. And then over time, there is this workflow of like peers updating each other of like the topics that they're still interested and the topics that they are not interested in anymore. There are two types, there's like 2 special types of messages with regards to gossip, which is the graft and the prune message. Graft is when a peer, given its local interpretation, like his knowledge of the network, decides to ask another peer to, well, be friends with, basically to create that reciprocal peering agreement. And then pruning is the reverse. So it's when either a peer reached like the high watermark of number of connections, or as some reason, for example, he's not interested anymore in participating in a topic, like he can tell other peers that, hey, like I'm going to close this connection. We should not like send messages about this topic anymore. One thing that we added with gossipsub that was a big ask from our users is to have message validators. So in addition to the validation of the messages that gossipsub does, you can also hook your own message validators, like checking its signature, for example, or checking the validity date, or even like having an external service that you check that message against that external service. It's really up to you, the user, the implementer of the application on top, to decide what this message validator does. And so in kind of like a few pictures view, right? The gossip messages are sent through the dense network, so the metadata network, and they carry information about like subscription changes, messages that the peer has seen, messages that the peer hasn't received and wants. So one of the properties, and to kind of mitigate that problem from random sub where a peer would not receive a message, given that other peers are telling them which messages they have received, now a peer can like be proactive and say, hey, I haven't seen that message. Can you provide it to me? And so this is kind of like a way for the network, again, not necessarily to like rebalance itself as a whole, but like to create a framework in which peers can help each other over time. And this gossip, so we didn't want to add too much work by adding gossip. So like we structured the gossip to be sent in a heartbeat. Right now, it's like every 1 second, but again, parameter, you can adjust this. And peers will send like this gossip like every 1 second, and they will only pick 6 metadata only peers. And for the ones that they have a peering agreement, so full message peers, they will also send gossip, but they will piggyback that information on the data messages so that we don't like create extra messages without a need. And so you saw before the flood sub. Now let's observe how gossip sub behaves. So you can see gossipsub is way more light. We don't see those balls of red anymore. You can see that like peers are way more calm in terms of like sending messages to each other. We see some orange nodes here, and the orange nodes means like that some node is emitting gossip to each other, and that's just like to again to transmit the messages that I described before. The setup of the network is similar to the before, so 100 peers, 5 messages per second. Run for 2 seconds, expand it by 10 times so that we can see it as humans. So maybe rather than like watching it till the end, the best is really to see them side by side and just see the difference. So I accelerated this by 4 times because I wanted to save everyone's time. You can see, well, I guess you can guess, but on the left is clearly flotsub, and on the right is gossipsub. And so this is like the same amount of messages, the same amount of peers. And there you go. Flotsub has done it, like has finished. Again, flotsub really optimizes for latency, so has delivered messages way faster than gossipsub. Of course, like when you scale this up, when you add more peers, when you add more messages, if you have a limit on the bandwidth, and I believe we all do because we so far cannot overcome the speed of light, so I think we will always have a limit on the bandwidth. But like as we increase the number of messages and nodes, gossipsub actually starts losing to flotsub actually starts losing to gossipsub just because flotsub will like choke on itself over time. So by the way, these visualizations you can see at the bottom. I believe there is a link here. Maybe display bar is like, I'll share the link after, but you can like use the tool that was built for this to generate more visualizations as well. So recap what we get with peer-to-peer PubSub. We enable applications to get real-time updates on a peer-to-peer network. We have resiliency to network churn. We have a lot of like adjustable trade-offs. So this really depends on like what application is doing. And we are able to scale, like thanks to gossipsub, we are able to scale to larger networks with more messages, more users, etc. But this is not all. So the other thing, this is kind of like a very brief overview of like how gossipsub can be used and like how it works. But then there is this extension that we've been working on, which is to harden gossipsub. And we call it the gossipsub version 1.1. And so version 1.1 is about creating extensions to mitigate attack vectors. And so I summarize here like some classes of attacks. We have found 12 variances of these attacks, but like just to make a summary and to paint the picture for everyone, I summarized it in 3. So one of the classes of attacks that we were concerned about is the civil attack. And this is when nodes join with the intent of causing harm to the network. And they can potentially, replicate themselves to squat entire areas of the network. Basically, just either control the flow of messages, like degrade the quality of service, or just like keep certain nodes out. And when they keep certain nodes out, we actually are talking more of like an eclipse attack. And so this is when we have a malicious node that actually controls the channel to some other nodes. And so that malicious node can decide which of those messages are going to be seen by those nodes. And so this creates a problem where that node has power over these other nodes. Then there is another type of attack, which is the spam attack. And so this is attackers, malicious actors, like figuring out details of the protocol where they can send a lot of specific messages to other nodes and like force them to do a lot of work. And by forcing them to do a lot of work, they kind of like either exhaust themselves in like CPU resources, memory resources, disk resources, bandwidth resources, etc., to the point where they cannot like operate anymore. So mitigation strategies that we came up with for these problems. Disclaimer, I'll just say the spec for video 1.1 is like 3, maybe 5 pages tops long. It's really like I'm really proud of the team that like created like a spec that is very easy to read and like to parse through. And I recommend everyone that is very interested to check it out, because I'll try my best here to kind of like explain all of these details, but hey, limited time. And like, this is where things get a little bit more complex. So bear with me as I go through the mitigation strategies. Mitigation strategy number 1, so peer scoring. So this is very common, like when you study the literature on peer-to-peer networks and how to maintain malicious actors out, like often you talk about reputation systems. And so we implemented that. We now have a way to score the contribution of each peer. And so each peer keeps record of the contribution of every other peer that it meets throughout its lifetime, throughout its life cycle, for each topic, right? So we could have a peer that is very benevolent on one topic and very malicious on another one. And then we give a bunch of parameters that applications can adjust to describe how important certain features are and how we should like score those peers for those features. So we have things like time in the mesh, the number of messages that node gives us, and like that's the first time we hear about that message. The expected mesh message delivery rate. So this means like if you have, like for example, an IoT application, and you expect like sensors to give you data every second, then you can set up that threshold. And like if it's higher than that threshold or below that threshold, you can also like adjust the score of the peer because probably something is going wrong there. Then like of course invalid messages, and like applications can have their own specific score. So if you have already, for example, a reputation layer at your application level, you can just like inject that information into gossipsub itself, and it will use it to make judgments about how the usefulness of each peer. Then there is flood publishing. So when the score of some peers goes below certain thresholds, we might decide, like we have this option, might decide to just like do a little bit of flood publishing not for the entire network, but just like for nodes that are around us. So instead of like just sending to the ones in our mesh, we actually send to the ones in our mesh and to the ones in the metadata network. And this is a way to kind of like get that property back from flood sub, which was robustness. Like make sure that like if an attacker tries to eclipse us through our agreed path, so through our peering agreements, we can always like default back to flood publishing and just like use other paths to get the messages through. Another thing that we added was peer exchange on prune. So this is effectively a peer discovery. So when a peer tells the other, hey, I want to close this connection with you, it can actually give that peer some new peers to connect to. So rather than that peer having to go again on some ambient peer discovery, like some DHT or some like centralized database or whatever, the peers can help each other, like just finding new peers to connect. Then we have spam protection. So basically, we ignore certain types of messages. Like so, when we don't know the topic, we had never heard about the topic before. We rate limit the I want responses, and if we actually see that the peer is actually sending a lot of the spam that we are ignoring, we will cause an impact to the score of the peer. Another thing is explicit peering agreements. This is very useful for applications that have federation, so that they have multiple clusters that are federated, or even organizations that want to collaborate with each other. And so they have a federation among themselves, but also they have a public network that everyone can join. And so they can have an explicit peer agreement between those organizations, between those data centers, between those machines, and like make sure that gossipsub will never close that connection and will keep it alive for them. Yeah, so again, as I said, really recommend going out through the spec. It should not take you a lot of time. I hope I sparked your curiosity by like just highlighting what are our mitigation strategies and the attacks that we were looking for. And yeah, so we are not done just yet. We have still some work to do. And so I'll just like highlight like what we are doing right now. We have created an evaluation plan for gossipsub. So out of those class of attacks, we expanded it into multiple variants of attacks, and then we converted those into test cases. Fortunately, we have a tool now that we created also at Protocol Labs called TestGround. And TestGround is a platform that enables us to spin clusters with different topologies, with different like network latencies, with different connectivity levels, and to gather all of those results out from a run on that cluster, and then to process those results in a way that we can like take insights. So what we are doing is we are grabbing all these test cases, writing them as test plans, running them on test ground, and getting the results back. If you are interested on test ground, like this deserves a talk, like a whole section of its own. So we'll be running an onboarding session soon. Just stay tuned. Just show up on our channels, like discuss.ipfs.io, or even go to the repo directly and open an issue sharing your interest, and we'll make sure to invite you. One really cool contribution that the gossipsub team made to the test ground team is this Jupyter integration in test ground. So we now have this ability to have the test plans written. So someone can open a test plan, and then they get this really nice UI thanks to the Jupyter notebooks, in which rather than adjusting a bunch of command line parameters, they can just adjust some knobs like network latency, connectivity of each peers, number of peers, etc. They can just click run, and it will send that instruction to our test ground cluster and simulate that network, get the results back, and then you can run and visualize the results on your local machine. And you can even adjust, tune those visualizations. You can create other visualizations. You can share those visualizations, just like Jupyter notebook style. So this becomes really powerful because we get the chance to welcome a lot of networks researchers to just use everything that we have implemented and do their own analysis and take their own conclusions. We are producing a gossipsub report to be available soon. I'll take the honor of sharing this community when it's ready. So to wrap up, and I know that I'm over time, I'm sorry for taking so much time, but yeah, you can try it today. Goalie peer-to-peer PubSub is available. Our reference implementation is in Go. So if you like Go, if you use Go, we have an implementation ready for you. There will be also other implementations in other languages. Well, for version 1.1. If you want to use version 1.0, so the one without the hardening extensions, you can use it in JavaScript today, Python, Java, and more. Pretty much last but not the least, I really want to praise everyone that has been contributing to this project. It's a very, very big team over many years. So this, from peer-to-peer PubSub to FlatSub to RandomSub to gossipsub with hardening extensions, a lot of people have worked in this project directly, either by implementing code, writing the specs, doing the tests, or indirectly by producing the research that inspired us. So I really wanted to thank everyone that has participated in some form or the other. And this is where I end with a thank you to everyone. Thank you again for inviting me, for letting me share this update. And yeah, if you want to chat with us, come to the peer-to-peer channel on Freenode, which you can access through the matrix.org bridge using Riot. That's what I do. Or you can just jump into our discourse forum at discuss.peer-to-peer.io. And that is it for me. I'll stop here. Now I'll stop the screen share.
Thank you. Fantastic. And I actually understand gossipsub, or at least I understand the level of detail that you gave us, which is
that's great. That's a great start. Well, that's perfect. Yeah, I'm happy to take questions, or
we have a couple here. So a couple from Timo. So this is more about general libp2p. So if I have two different applications that both use libp2p, will they share the same network?
That's a great question. So by default, when you either install an application like IPFS that connects to the main network, so you will have access to the same network. But that is not a limitation. You actually can install libp2p on your application, and rather than on the config file, rather than say bootstrap to the main network, you can have your own bootstrap peers and create a completely disjoint network. There is one more feature. We have this thing called the private swarms. So you can actually, when you start the node, you can say, I want to connect to the main network, but I only want to be connected to the nodes in the main network that share a private key. So that share a pre-shared key. To use the right terminology. And so every time one of those nodes connects to another node, it will do the secret handshake, and it will decide to dial or not to dial. So it enables you to still use the global mainnet peer discovery, but only have effectively connections to the ones that you are interested on.
Gotcha. All right, that makes a lot of sense. And then the next one, how much work is it to use this in an application? So if you wanted to get the benefits from it, what would be the steps required for a developer who doesn't necessarily care about these details?
Yeah, absolutely. And so the defaults are pretty reasonable, but then again, they are the defaults. And what I expect is as your application grows, you will have to tune the parameters as pretty much like any other software stack, right? But like effectively, you would have to import the Go peer-to-peer Go package, and so just like using normal like Go mod or like Go get, whatever you prefer to use these days, and start a new pub/sub node, and it's like name of the package, new pub/sub node, and then from that point on, you have the function called publish and the function called subscribe, and so you can subscribe to a string, which is a topic, and you can publish some data to that topic, and that's it. So you can create a chat application in like I feel like less than 20 lines of code. Well, maybe more because it's Go, but like very quickly.
This is what Matrix libp2p is doing, as I understand it. I mean, my understanding is quite small.
Well, yeah, I mean, it would be really, really exciting to play with the gossip stuff. At the moment, we're using JS libp2p in p2p.riot.im as the way to go and create the mesh between the different P2P nodes. But I know that Neil Alexander is looking at putting the Go code bases into Riot iOS, and that would be an opportunity to both put in the gossip stuff implementation in Go. I think he's also looking at putting Yggdrasil in there too, and seeing how the two very different approaches compare with one another.
That's phenomenal. Well, yeah.
Cannot wait to play with it.
Yeah, and like it's fully interoperable. Actually, like we made it backwards compatible. So like between implementations, it's interoperable from protocol design, and then we made it backwards compatible where gossipsub 1.0 can talk with flood/sub peers, and gossipsub 1.1 can talk with gossipsub 1.0 peers, which by design means also it's able to talk with the flood/sub ones. So if you have like, for example, the web app like p2p.riot.im using flood/sub because you have a smaller network and maybe that makes more sense to use it there, and then you have the mobile application using gossipsub, they will still be able to find each other and exchange messages.
Very cool. We'll have to give that a go because it would be really cute to have the Go implementation on Riot iOS talking through to the JS implementation.
Yeah, that's very exciting. Keep us posted. Yeah,
we shall. I had another question actually, and that's Ben. Am I going to get into trouble for hijacking?
We've got one more question, but ask your question.
Okay, it was on the message validators thing, which sounds really interesting. To if you're letting nodes basically apply arbitrary rules on the messages going through, how do you express those rules?
Yeah, you get the message, like you basically create a function, like you get the message, you validate it in the way that you want to validate it, and then you just say to gossipsub, like this message is not good or it's valid, right?
Oh, so it's just hooks to your local node. It's not some kind of shared compute functionality over multiple nodes.
No. So yeah, like as well, that's interesting. So what you're saying.
I was just checking there wasn't some kind of distributed virtual machine thing going on where all the peers
not yet. So I guess I can just like mention another project which, all the pub/sub messages that go through flood/sub, gossipsub are IPLD nodes. So IPLD stands for the interplanetary linked data, which is this is like data model that we use to build any data in IPFS. So one of the things we've been discussing for a while and that we really want to pursue is the ability to have like a type system that is distributed that like enables us to create constructions, not only just like the data itself, but also the computing over the data, and then use WebAssembly to like do it once, compile it, distribute it over the network.
Right, that's precisely what I was wondering, whether that was what you were trying to do. But...
Yeah, so once we get there with IPLD, we'll be able like to plug it into gossipsub. But
cool.
That's such a exciting direction to look at, because then we can have like applications that like run forever and keep upgrading itself. And then because WebAssembly and like injecting code into a WebAssembly VM is done through some path, you can just like pass a CID, so like a content identifier, and then you know that you are injecting the right code because you can validate its integrity. Well, just a lot of benefits, but I diverged.
That's cool. Ben, sorry for hijacking your final question.
We've got just a couple more questions. How do you reconcile the initial goal of a real-time protocol versus the eventual consistency of gossip? and it just says similar to console but distributed.
That's a great question. And what we ended up doing is just like giving more and more power to the user in the end. And so have like reasonable defaults to start with, like reasonable defaults that like scale well for like small networks, like to thousands of nodes, and that give you like the properties that you're looking for. And that's also what we get out of those simulations that we run with testground. We actually get to test multiple network topologies, multiple interaction patterns under specific attacks, and see how the whole network behaves and adjust those parameters. And then like, so the report will have some kind of like recommendation saying, if you are building an application like this, consider these parameters. If you are building an application like this, build these parameters. As the one application grows in terms of users, numbers of nodes, numbers of messages, it will always be kind of like a cat and mouse game where you kind of like keep tuning these parameters up until you find the optimal, like the minimum, right? Like the thing that like, for also the resources that we have available, because if you have more computing power in the network, if you have more bandwidth, you can just like be on the spectrum closer to flat sub and like minimize the latency. But if you have less resources, like, well, you have to compromise and like increase the latency to save on the resources. One of the things, and this is like really like sci-fi right now, like we don't have anyone working on this, but like we are really inspired by the congestion flow algorithm from TCP REMI, which just uses machine learning to evaluate a lot of like data flows to understand how to figure out what is the minimum, like what is the optimal set of parameters to optimize TCP. And so there is this really beautiful diagram, which is like all the TCP research over multiple decades. And you can see that like there was not really much progress after a certain scale. And then someone, this TCP REMI, and like it just completely blew off the chart, right? Like they had to increase the chart to be able to just like point this implementation on the chart, because like the thing that the machine learning algorithm figured out was like so much more optimized than everything else the humans were doing manually by tuning parameters. So yeah, once we have like the ability to simulate all of these interaction patterns and like network scales, then we can like just start an endeavor of like just inviting the machine learning researchers to like figure out if they can optimize this even more. So that's like something we were looking for. But again, it's very sci-fi right now. Like it's
quite sci-fi.
Say again?
That sounds quite sci-fi at the moment.
yeah, but like I think we'll figure out at least like new parameters that will be even better for for niche use cases, right?
All right, so the answer really is configuration is the key.
Yeah, configuration is the key. You'll have to like see what your network does and like scale it up, or adjust it as you scale it up. But also like we do everything in the open, so like everything like code, specs, forums. Like if you have a very specific use case or network, tell us about it. Like we are always interested to know how people are using it, and like we are more than happy to support you figure out like what are the right parameters.
So thank you. So there's one late breaking presence support. So something like last will in MQTT, is that possible?
Last will and MQTT present support, if it's possible. Well, not that we. Well, you do
like application level rather than at the protocol level, I guess.
Say again?
Wouldn't you do that at the application level rather than the protocol level?
Well, I think you can do that at application level, most certainly. I'm just thinking like what will be the best way to hook that up into the protocol as it is designed. And so, yeah, like you can rely on some of these nodes' local knowledge. Like, so each node has like a partial view of the network. You can see what's been up, what's been down. But like, at the same time, like I think for those applications that really benefit from that feature, you also want to have some kind of way to link the peer ID, like write a node ID to the actual application ID to the actual user, so that you can then have this like knowledge that like, okay, this user was present because it's referenced to all of these peers. And so that right now, there is no like primitive for that. But I also would say that if we were to build something, it will be like a layer above, not a layer underneath.
David, thank you very much. That was really great. Yeah, I think everybody's a little bit more educated about the inner workings of IPFS right now, or LibP2P in general. So thanks. All right.
Yeah. Thank you so much for this opportunity. Yeah, I'll stick around to see the next one.
Yeah, please. So the next one, I think everybody knows, Valère and the Riot team have been working on cross-signing, which is to say the sharing of encryption keys in order to just improve the UX of end-to-end encryption for instant messaging. And he's going to do a demonstration of that now. I hope and think that he's going to use like multiple mobile devices at the same time to give us some crazed interactive demo. Here he is.
Yeah.
How's it going?
Hi, thanks. I will try because actually my system just crashed, so I hope it will work.
I mean, it's all very stable, so you should have no problems. Good luck.
Okay. So I will explain the setup here. I'm going to do a demo of cross-signing. So here you will see on the left of my screen, I have a session, it's Alice, and on the right, it's Bob. They both have cross-signing enabled, and I will try to keep the color scheme. White will be Alice, and black will be Bob. So as Matthew said, cross-signing is really the final stone that we needed to push the button and enable end-to-end by default everywhere. But it's not the only one. A lot of things has been going on encryption, also on search in encrypted room, but also a lot of small UX things. So as you can see here on the left, I have a private room created by Alice. So you can see here that I have a nice thing saying that encryption is enabled. There is also some history. Here Alice typed something. And now Bob has been invited. You can see Bob here. The first thing you can notice is that we have the black shields. Prior to that, you would have warnings everywhere because the devices are not verified. But as long as you didn't make interest into verifying, you will see the black shield. Black shield is okay. It's end-to-end encrypted. Also here, Bob do not have access to the historic because he was not there at the time it was encrypted. So there is no way he can decrypt that. And now it's just clean here instead of having tons of warning. So first thing I'm going to do is I'm going to create a direct message with Bob. So let's go. So I create it. So I can see the invite here and I can start chatting. And as you can see, encryption, end-to-end encryption is enabled by default. As you can see here, I will say, hi, Bob, because I'm Alice. Hi, Alice. You can see that it's live. So cross-signing is only interesting when you start having other devices. So let me launch an emulator. I'm launching it only now because it made my system crash. So hopefully, so it's a white device. So it's Alice. I'm Alice. I'm now installing RiotX. So the address here is a bit strange. It's because I'm connected to a local server. So I'm going to log in as Alice. Okay, so first thing you notice here is that on my previous session on web, I have a toaster saying that there is a new login and asking if it's me. And on the new device, I have a complete security. So now I will be able to enable security on the device when I install it. So of course, on the left, it's asking me if it was me. So it's me. Part of the enhancement done in verification was to add more options to verify. If you remember, we started by comparing a number, we added emojis, and now we have QR code. So I'm going to try to use the QR code with the emulator because first it's fun, but I have to do some setup. I will first have to save that as Alice QR. It's just to say to add it to the emulator because obviously the emulator do not have a camera. Okay. So I'm going to add Alice QR. Okay, so I'm going to tap scan the code. So it will open the camera with this fantastic app. Yeah, I'm in a real flat, and I can, navigate the room.
This is so silly.
I wonder who did that and why. So I'm going to go, and it's on the wall. Yeah. So let's go back to the browser. So as you can see here, it's asking me on the web if it was scanned correctly. It's a protection against eavesdropping. So I say, yeah, it was me. Got it. And so look, it's magic. I have here access to the room. I have access to the messages and to the encrypted messages. You can see I have access to all the other messages. It's really nice with the cross-signing. So something another thing happened here, and I'm going to demonstrate it by talking with Bob. So I'm with Bob here, and I'm going to verify him because let's say I move to Bob's house, I see him, and it's a perfect occasion to try to verify. So I start the verification. So I can see that Bob received the request. So I see accepts. Let me show you. This, sorry about that, it's annoying. I'm gonna put myself here. So I have again a QR code, but this time let's try to scan. Okay, so I have to check the emojis. So butterfly, paperclip, big lion, flag, glasses, lock. Okay, they match. Okay, they match. If these things match, you are sure that you are not. There is no one trying to do a man-in-the-middle attack. Oh, and of course it did fail. As I suspected, the crash did break something.
Yeah, I think you just clicked the didn't match button.
No, that's true. I did that?
Yeah, you did.
Okay, so I was
Try it again.
Okay, I try again.
Oh, it was right. The colors were different, so it didn't match.
It's the emoji curse.
They match and they match. Oh yeah, okay. So there is already something new that happened here thanks to cross-signing. Is that Bob now, as you can see, if I'm going here and I talk to Alice from here, I'm going to reduce the size of this. Previously, I would have a pop-up saying, hey, there is an unknown device here. Because, of course, the web Alice device, I have never verified it. And this is the magic of cross-signing, is that now I can see that Alice has 2 verified sessions. This is because now with cross-signing, you have kind of an identity, public-private key, and you can use it to sign your devices. So basically, by doing the verification at the beginning, Alice has certified that this device and the other one are from him. So that's why everything is green. So previously, if you had like 10 people, which everybody has 3 devices, you would have to do the verification for every devices and every user. Now you just have to verify the user once. So it's really, really a great progress. So now we're gonna add a new device from Bob. So as I said, Bob is black. So let me add the black device. So we are Bob and Bob. It's again a self-verification. I'm going to show you now how it works. Let's say if you lose your device or you don't have access to it. So it's still HTTP : sign in. Okay. So I am signing in. And this time I don't have access to this device. But thanks to the bootstrapping, I have been able to make a backup of my local secrets. And I will be able to, thanks to my passphrase, my complex passphrase, will be able to recover everything. Oh, you can see here that Bob is red. And now it's green. And I don't know if you've seen it. I will show you after. So I have completed security. So here, thanks to this passphrase, and I have it's really now, I have access to my history. You can see it. So Riotix is still showing you the history that you cannot read. That's why you see that those messages. But this one, I'm able to see it. So that's why it's working fine. Here also, I can see that I have access to my history. So this was the recovery thanks to a passphrase. Yeah, I said I'm going to show you what happens. So here I can see the session, Bob session. I'm going to sign out and signing again. So this is now really so easy to add and remove devices with Matrix. You don't have to re-verify everything. It's really, really a great progress. I don't know if you remember that people were afraid to add devices. They have to re-verify everything. Okay, again, I get this loopback address bad. I'm going to sign as Bob. This time, I'm not going to verify. So you can see here, previously this room was with a black shield. But as I expressed interest into verification, and I verified Bob once, now I have a red shield. So it's saying, hey, this is strange, you verified Bob, and now there is a new device that is not trusted yet. So this is why it was black. Now, if I have verified, it would be green or red. Okay, so let's say it wasn't me. Okay, so I'm going to log it out. This is how you do it. If it wasn't you, delete. And you're good. It's back to green. Next one, I didn't show you my iOS emulator. I have that also. So let's see how it looks like on iOS. Okay, I'm gonna log in as Alice. It's just to show you the experience cross-platform. So here I have a new session. You can see I have a pop-up. I will have it also on the Android device. Okay, you see here, they are all telling me that I have a new device. I need to verify it. So I will verify from web. So it was me. I will compare the emoji, and it's Encore, key, dog, gift, fire, Encore, flower. This time I'm going to click on the match. And so it's done, and let's check for Bob. So Bob doesn't have to do anything. It's still green, and Alice has free trusted session. So that's it, guys, for the demo of cross-signing. And if you have any questions.
Thank you. It works. It
works.
It works.
It's like every combination possible there between Androids and iOSs and webs, and rather than, shall we say, the happy case that we demonstrated back in FOSDEM, which had just landed on develop, I think the night before, Valère and I and a few others were like in the hotel bar at 2 o'clock in the morning, frantically trying to get the happy path to work. Now we have both the happy path and all the other paths working too. So that's why I say that on Thursday, hopefully, we should be able to flip the switch and everybody can finally use this after months in the making.
On that subject, so Timo asks, "Oh my God, so many devices! How much RAM does he have?"
I have tons of RAM, and I have to kill the Android emulator with the Doom camera because it will kill it.
Right. So Oleg asks, which versions of Riot X and Riot Web are those? I'm guessing this is basically just develop plus.
Yeah, I took all the risk for the demo. It's develop.
Yeah, all right. It's just the bleeding. And then the remainder, there's lots of some UX remaining. Things like sometimes the buttons are switched depending on your platform, I think. But yeah, I think that
there is polishing to do, and
yeah, most of the remaining questions of that. But seeing the demo working is phenomenal. Thank you.
Are there any other questions? Thank you, Valère, by the way, for going and showing us through it. And I also thank you to David and Saúl. I think Saúl just dropped, but it was very, very cool to see all the gossipsub stuff there and the Tales of Jitsi. But any other questions for Valère?
Well, I have one, because this is such like an elegant system for managing keys and distributing keys with your friends and like verifying them. I wonder if you are planning to keep this within the Matrix ecosystem, or if you're actually planning to expand and actually become like a really good key manager.
Shocking, the IPFS guys want to steal our key management. Quick, everybody. You know, it's funny because what we've got here is kind of a bit like Keybase, except it's gone completely the other way around. Like Keybase started off obviously as a key attestation and key management system, and then they kind of added chat on in order to make their key management more useful, frankly. Whereas we've kind of done it the other way around. We started with chat, and then we've added on all the key management stuff in order to make the chat usable for encrypted stuff. There's nothing stopping us from using it outside of Matrix. Obviously, just like you can use Keybase as a way to attest identity for any old random protocol, and they recently expanded it so you could just add in your own attestations via an API. I think we could do a similar thing on this. Obviously, the way to do it, though, is to just combine together the E2E keys with libp2p keys and peer-to-peer matrix, and then it all becomes the same thing anyway. So,
well, but again, like this UX part and the fact that you can like just like verify the keys from your friends. One use case that like is beyond just like attesting one key is actually the ability to fragment a key and distribute it through multiple friends, right? That would be like super useful and apparently simple, given that you already have the chat, you already have the messaging, and you can already verify the identity of your friends. And so in case if you lose your keys, which is like a recurring problem, especially nowadays with people like holding crypto assets and whatnot, it would be very interesting to see this system enabling us to recover keys by just having multiple shards through like in multiple friends. And then as they verify that it is us, they can give us their piece so that we can recover a key. And I think there's like multiple like organizations and projects trying to create something like this, and it seems like that what you have in Matrix is just like the perfect platform for that.
Yeah, no, I mean, it certainly could be used elsewhere. God, there's something I was going to say, totally gone from my mind now. The social recovery stuff is interesting, and it's something that we've looked at for kind of audit compliance. So if you're using it in some enterprisey case and you need to have the ability for somebody to audit the logs in retrospect, a really nice way of doing it is to go and take the keys, split them up, and give them to separate people who would have to explicitly come together with the correct legal process, blah, 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 to go and reassemble the key in order to get back in. And also the idea of having kind of intermediary keys which can attest for users on the system. So you have very simple transitive trust, because at the moment, everything we've done is still point to point. I have to trust you. I can't delegate that trust to somebody else, but we have the infrastructure for it. Oh yeah, and that was the other point. That it's obviously all spec'd openly as MSCs, which are the matrix spec changes, which then update the matrix spec itself. So even if somebody wanted to kind of fork it out of Matrix and make it more generic, all the information is there. And we've gone through a lot of iterations now, I think 4 iterations of the design, until we finally got one which is working really, really robustly. So if nothing else, people can pick it up, but we can certainly look at trying to factor it out of Matrix so that you can use it for PGP, or I guess more of the AutoCrypt style use cases. We speak to the AutoCrypt guys quite a lot about solving the same problem for them, or indeed assets and things. Sorry, that question was actually for Valère, I guess, before I totally hijacked it. Sorry, Valère.
So on the same, so we've got a couple more questions. I think Valère can probably speak to it, but anybody's free to answer. Regarding the ordering of messages and particularly of invites, is there a way to handle this cross-signing, but for messages that are sent an encrypted pre-invite?
I don't get this one. An encrypted pre-invite?
So if somebody is invited to a room after an encrypted message has been sent,
yeah,
how can they then decrypt that? Is that ever going to be possible?
I mean, the SDK can allow you to share more keys, but the thing we are doing now is that we only share the keys of the thing you were supposed to read. But it's totally possible with the SDK, depending on how the client keeps the key material, because technically you can decide to delete the key material on the fly. But currently, Riot will not send you the keys for the history.
Yeah. Okay. I mean, that makes sense. I mean, it's forward secrecy.
I mean, somebody asked the same question at Fosden, actually, and it's quite a convoluted answer in that there are many, many different paths through what it means to try to encrypt to somebody before you invite them. For instance, if it's a user that you've never seen before and they haven't accepted your invite, you need to somehow subscribe to the devices that they have, including updates to those devices, which could be a massive denial of service problem. If I say, hey, I want to send an encrypted message to David, but I don't know what devices he has, should I be allowed to subscribe to an infinite pub sub feed of all of his device updates without him ever even have accepted my invite? You can see that you could easily just go and loop over inviting people to conversations, and even if they don't accept, you then start putting a load on their server to keep you updated with all of their devices, as well as being a bit of a privacy risk. So that's the kind of biggest problem that we have there at the moment. You can take a snapshot of the devices somebody has at the point you invite for them, and in theory that should work because I implemented it, and that it should go and tell your Synapse or your home server the keys which the remote person has, so that you can then start encrypting for those keys. You don't get updated if they add new devices, but that's a bit of an edge case. But in general, that should work okay, unless, as Valère was saying, you're deliberately not sharing the history before they join the room. And that's a totally separate problem, where if you join an encrypted chat, and the messages before you were even invited to it, why should you be able to see those? You would have to explicitly go and share the keys out of band. And we've spoken about doing it with a kind of limited key export, and you can literally say, hey, I'm explicitly just going to destroy the security of this room by exporting the messages or the message keys and sending them to the other person. And it's kind of the same as doing an analog gap style thing, like you copy paste it out of the encrypted chat thing and put it in email, then obviously you're going to break the security. So we could do something like that, but it's not high on the list of things to do, given you could just copy paste it at that point.
So a few more questions have come in, but we're a little over time. There's one which is...
Folks, I'm just going... Sorry, I didn't want to interrupt, but I just wanted to say proper goodbye because I do need to jump for another call. And so thank you so much for having me. Thank you so much for this virtual meetup. Please organize more. Yeah. And thank you everyone that watched the live stream and for the questions, and see you around soon.
Thanks, David. Lovely to see you again. Thanks for coming.
Yeah, bye-bye.
All right, so I think we should just do one last question, which is basically, what's the status of RiotX replacing Riot, and does the E2E rollout depend on RiotX?
Over to you, Valère.
No, it's for you.
So first of all, the E2E rollout, I guess, does slightly depend on RiotX because it's just not implemented on Riot Android at all for the cross-signing stuff. However, it's not like Riot Android is going to get any worse than it already is. You're still going to be able to send and receive encrypted messages, but it's just not going to be reliable. At this point, basically everybody should be on RiotX, I hope. The only big feature I'm aware of or missing is the Jitsi integration, but that can be done very easily just by linking to Jitsi if needed. The plan is to ship RiotX as soon as we can after this. And whilst we've committed to a day now for turning end-to-end on next week, Valère, do you want to commit to a day for RiotX?
I want first to thank all the people trying RiotX. They are helping us a lot. So, I mean, there is nothing preventing you now to add RiotX and Riot on your phone. With cross-signing, it's okay. And it will help us a lot. And of course, the main thing people are missing is calls. I mean, one-to-one calls and Jitsi. Probably some other things, but they are the main complaints for now. So it will be soon, but you can already jump. There is nothing preventing you to use it.
Great. Yeah, everybody should be on RiotX. That's the punchline, I think. Yeah, just get using it. Okay, great. So there are a few questions left, but I think we should probably call it. Any more questions, people can ask them in the Riot specific rooms, I think. So yeah, actually, Saúl and David have actually gone already, but I want to say thank you to both of them for being involved in this first meetup, and thank you for Valère and Matthew for presenting the current state of the art in Matrix land, and thank you everybody for getting involved in this first instance of Open Tech Will Save Us, because yeah, it means a lot. So thank you very much.
And yeah, give us feedback. Let us know whether we went too long, too short, what sucked, what rocked. And thank you, Ben, for organising it.
Cool. I will get some sort of survey out, I think.
Awesome. Thanks, everybody.
Thanks, everybody.
Bye.